Today what we're going to be doing is we're going to be developing a rack and pinion. And what this allows me to do is connect a motor to my purple pinion here, have it rotate, and then turn it into linear motion through my yellow rack down here. A couple things to note before we get into it is this intersection right here. If I zoom in, we can see that there's very minimal space between the teeth of the rack and of the pinion when we zoom in. And that's referred to, that gap there is referred to as backlash. In other words, when we go one direction, how much does the tooth have to correct itself when it goes backwards, and it's going to jerk a little bit there. Typically you have to have backlash in machines because it's going to allow the machine to function properly, whereas this might bind a little bit. We're going to be doing this with a laser cut, and what that means is when we make the cut, it's going to cut directly on the line. It's actually going to make the part smaller than it is, and so it's going to sort of build backlash into our system for us. It's also going to provide us clearance down here at the bottom that we're not going to have to worry about. So I'm going to go down, and I've just got a new part studio up where I've already got it developed. And let's just walk through this. So I started off just using the feature script for spur gears, and I went in and I developed a gear that had 16 teeth. You want to keep it below 18 teeth on your pinions. It just is going to make things work a little bit better for you. I wrote down my module right here because that's going to be helpful for making decisions later. I changed the pitch of my circle to make the module a little bit easier to work with. I'm not going to mess with the 20 degrees, and I'm not going to mess with the 1/3 of the quarter here. This is just the extrusion depth or the thickness of my gear, and so I've got it at 0.2. I then went in and added a hole in the middle of my gear, and then we started the sketch down here, and let's look at it. So let's identify some things right off the bat. This grayed out construction line is my pinion pitch circle. This construction line that is horizontal to it and also tangential is my rack pitch line. And we're using that to set up this angle right here, which is my pressure angle. And that's referring to the angle that the gears are going to be at when it comes into collision with the rack. This circle right here is going from the intersection directly from my origin down to the rack pitch line. And then I've just set it to be tangent to the side of the tooth right here. The blue circle, which is also a construction line that's a little bit smaller than it, is setting my backlash. Now with those in place, what I can do is I can start drawing the tooth for my rack. So I set a line right here, and I set it perpendicular to this line right here using a constraint up here. I then took it and I mirrored this line across this axis here so that they stay similar as I adjust my circle. As I adjust it in and out, what that's doing is it's changing the amount of clearance or backlash that that gear has on it. And so in this situation, I'm actually going to set it tangent to the side of the tooth so that there is zero backlash. Once that's in place, I started adding dimensions, and so I have the module of my tooth, which is from the rack pitch line up, which is just the module. And then downward, I have it being just the module also. You will see situations where people have this increased by 15 to 20% to allow for some clearance down here at the bottom. I then just drew a box on the bottom. This 0.3 is arbitrary. And the value here is the distance to my next tooth, which is my module times pi. And that's going to be where it starts for me. Once that's done, I'm just going to extrude that. And then I'm going to do a linear pattern. Where what I did was I selected my first tooth. I selected an edge for it to go in that direction. I placed the same distance there, which is my module times pi. And then I added instances that I want, which in this situation was 12. Here's what it looks like. So now let's look at two more things. What we want to do is we want to see what it looks like on a drawing file. And so I just went over here and selected drawing file and pulled in the side views of both my parts. And then I can take that to the laser cutter and be able to cut that. And let's also look at this rack and pinion animation so we can check and see that our teeth are working properly. So to do that, I'm going to build a structure that looks like this. And what it has is it has a pin that this gear is able to run along, and then a flat surface that we can sort of use to restrict the rack with. And the distance between the center point of the circle and the flat surface here is the pinion pitch circle plus the module plus the additional width that we have down here for the rack. So with that in place, we're going to open up a new assembly file and get that built. So I'm going to start out by just inserting the rack. I'm going to put a slider mate between the face of this and that axis. We'll click check, and that should allow it to move back and forth now. I'm now going to insert the stand. And I'm just going to add constraints to that face and that face. Very good. And this face right here. And this face right here. I'm then going to bring in my pinion. And we're going to add a revolute between the back surface there and that surface right there. With my slider mate and my revolute in place, what I can do is I can use the rack and pinion mate that they have. It's going to go in. I'm going to select my slider. I'm going to select my revolute mate. My distance per revolution is going to be the 2.8 that I had times 3.1415. Let's see what it looks like here. We should see that it's moving similarly, which is good. The only other thing that I really need to do is go in here, and we're going to work with one of the mate connectors on a revolute mate, and right click, edit it. I'm going to select a move, and we're going to set it to be a certain amount of degrees. And once that's in place, we should be able to move that appropriately. Let's look at it from the other side. Good deal. Good luck with it.